Yes, so we want to introduce the concept of momentum. Well, linear momentum to be exact, because there is also angular momentum. Well, angular momentum, you'll get to do it when you arrive at university. That's if you'll be doing a Bachelor of Science degree that has physics in it. But if not, then linear momentum is the best you can do. Now, I want you to consider two situations, and this question is going to be answered by two people. I know no one is going to volunteer. It's not a tough question, really. So the first person to answer this is Riatlegile, and the second person is, we'll just take Carol. Two people randomly. Okay. Now I want you to consider two cases. Let's say we have two athletes, and these two athletes are running. They're running towards you. All right. Now, these two athletes, they have the following masses. The other one is a bit skinny, as athletes are normally skinny, so 60 kg. And the other one is maybe, let's say, 75 kg. Not bad. And they have the following velocities. So maybe let's say the 60 kg one is running at, well, maybe let's say he's much faster. So let's say he's running at 4 meters per second. How's that? And the other one is a bit slow. So he's running at, okay, can I do something here so that I can be accurate in what I want to say? Okay, let's say this one is running at 3 meters per second. Yes. And this one is running at 2.5 meters per second. Let's say that. So those are the two athletes. They're running towards you. Now, my question is, which one is much more difficult to stop? I know the word stop already means something is coming to rest, but just to make it clear, you stop the person and you bring them to rest. So that's the question. Which one is more difficult to bring to rest? So we'll begin with you, Riatlegile. Which one do you think?
So I think that it would be the 75 kilograms one because the velocity is greater.
But is the velocity greater though? The one that is running at, I should have said respectively so that you understand it's in that order. I'm sorry for not including this. It means the one who has a mass of 60 kg has a velocity of 3, and the one with 75 kg has a velocity of 2.5. It's in that order. Sorry, Elsie.
Oh, then the 60 kg one.
You say the 60 kg one is much more difficult to stop. Before I ask you why, what do you say, Carol?
So I say the 75 kg one.
You say the 75 kg one. All right.
Yes,
So let's begin with you, Ria. Why do you think the 60 kg one will be much more difficult to stop?
So because it has a greater velocity.
Because it, The athlete has a greater velocity. All right. What about you, Carol? What is the reason for your answer?
So I said 75 because I think it's more difficult to stop a heavier mass.
You think it's more difficult to stop a heavier mass? All right. Okay.
Yes, sir.
Okay. Now, thank you so much for that, ladies. I really appreciate your thinking. So both of you are partly right, not entirely, but you are right to some extent. So Carol is right in choosing the one who will be difficult to stop, and it's the one who has the 75 kilograms. Although her reason is shaky, but nonetheless, this is the one who will be difficult to stop. Why? That's because the athlete with a greater momentum is the one who's going to be difficult to stop. Now, the question is, what is the momentum of an object? That's a very good and important question. What am I writing here? So you need to know that the momentum of an object is defined as the product of the mass and the velocity of an object. That's what you need to know. In other words, if you take the mass and you multiply it by the velocity, you get what we call momentum. And this is the symbol for momentum. It's lowercase p. Now then, let's be practical. If you take the 60 kg and you multiply it by 3, well, 6 by 3, you get 180. So it's 180. But if you take 75 and you times it by 2.5, you get 187.5. So the pink product is greater than the blue product. And we know that the product is momentum. So the one that has a greater momentum will be the one that is more difficult to stop and bring to rest. Why? Well, that's because the one with a greater momentum is more in motion than the other one. Listen to what I just said. I said the one that has a greater momentum is more in motion than the other one. So what am I saying in simpler terms? It's not an official definition, but I want you to know that momentum is a measure of an object's amount of motion. The one that has a greater momentum is more in motion than the other one. That's what I mean when I say momentum is a measure of an object's amount of motion. Well, it's not my definition, actually. It was given by Sir Isaac Newton, well, back in the good old days. But yes, this is what I'm saying. This is the definition of momentum. Please make sure you know it. It's not difficult. They will ask you in the exam. Well, in less cases, in many cases, they ask you about conservation of momentum, but nonetheless, just make sure you know it. Yes, once again, I appreciate it, ladies. Thank you so much. Now then, this is a question that is directed to Malishaba. Yes, Malishaba, please tell us what is the unit of mass in physics. Remember, mass doesn't have the same unit in physics and chemistry. So I just want you to tell us in paper 1 physics, what is the unit in which mass is measured in?
Kilogram.
Mass is measured in kilograms. Thank you, Elsie. So what about velocity? Can any volunteer tell us what is velocity measured in? Well, no one will volunteer. I should have known that. Oh, yes, Mamutolo.
So is it not meters per second?
Meters per second. So this is the official unit for momentum. Thank you so much, Elsie. The symbol is P and the unit is kilogram meter per second. That's the official unit for momentum. And the most important thing is momentum is a vector quantity. That's very important. And it is always in the same direction as what? Which direction do you think the momentum is? Like I'm telling you that momentum is a vector quantity. Which direction do you think the momentum is in? Can anyone take a wild guess?
So would that be the velocity?
A velocity, sir. Yes, sir. Thank you, sir. So it's always in the same direction as the velocity of an object. If the velocity is to the right, momentum is to the right. Velocity is to the north, momentum is to the north. Yes, sir. That is just that. Now, can anyone tell us what does the momentum of an object depend on? Well, I'll give you a hint. The acceleration of an object depends on the net force, right? Which means that the greater the net force, the greater the acceleration. So what about momentum? What does it depend on? I'll take a volunteer. Volunteer?
So the velocity?
Yes, it depends on the velocity, I'll say. Is that the only thing that momentum depends on? Thank you for that, Alcina.
Is it the product of the mass and the velocity?
No, not the product. So the product is momentum. What is momentum? Depending on exact velocity.
So would it be correct if I said the net mass?
What do you mean the net mass? Like
Meaning
the word
that the total mass of an object, so because as we saw in the first example that the 75 kg one was harder to stop than the 65 kg one.
Okay.
So wouldn't that influence our velocity depending on how fast an object moves now?
Okay, sir. Okay, sir. I get you, sir. I get you, sir. I get you, sir. I'm sorry about that. My sibling wanted to bring me food. It's nice having siblings in the house. Yes, yes, yes. I just don't want you to say the net mass, sir. But it does depend on the mass of an object. And the word depend means if you change the mass, the momentum will change. If you change the velocity, the momentum will change. If you change both of them, the momentum will also change. Now, I want you to know that the momentum of an object is not always constant. It changes. Does anyone know what can result in the change of the momentum of an object? Let's say, for instance, the mass of the object is kept constant. And maybe let's say the velocity, I'm telling you, the velocity is changing. But then what can cause the velocity of an object to change? Can anyone think of that? What can result in the change in velocity of an object?
So
Yes, Olsen?
could it be acceleration?
The what?
Could it be acceleration?
Well, the deceleration is the result. So what is the cause?
Is it friction?
Friction. No, sir. No, sir. But you're closer. Something causes the change in velocity. What is that? All right. Well, this means I've got to tell you, but thank you so much for giving it a try. The net force. Remember, according to Newton's second law, when a net force acts on an object, you said the object will accelerate in the direction of the net force. And what does the word accelerate means? It means that the object can actually speed up, that's positive acceleration, or acceleration in the direction of motion, or the object can slow down, and that's deceleration. But deceleration is not a scientific word. They don't like to use it. They prefer if you say negative acceleration, which means it's acceleration in the opposite direction. That's a much better word to use. So the point is, the net force causes the object to accelerate. And by accelerate, we mean that the object can either speed up or it can slow down. Now, what does speed up and slow down mean? Well, the word speed up means the velocity increases. And the word slow down means the velocity decreases. So if the velocity increases, the momentum will increase. But if the velocity decreases, the momentum will decrease as well. So the net force causes a change in the momentum of an object. That's what I'm trying to say. Okay, fine. Now then, you need to know that the change in momentum is defined as the final momentum minus the initial momentum. Well, you know this already. Change in x, it's final x minus initial x. Anything that is changing, it's always final minus initial. But now you remember that we said momentum is the product of the mass and the velocity of an object, which means we have mass times the final velocity minus mass times the initial velocity. So now you can see that the mass is the highest common factor. And when you take it out, you're left with the difference between those two. So you can now say, well, change in momentum is actually going to be the mass times the change in velocity. Because here we are assuming a situation whereby the mass is not changing. Like let's say for instance, the athlete is running. The athlete already has a mass of 60 kilograms. So what you can do is you can try to slow down the athlete by pulling him back, maybe with his t-shirt, if he's wearing a t-shirt in the marathon. Yes, he's still running forward, but you're pulling him back, so you're slowing him down. You see that you're not decreasing his mass, you're just affecting his velocity. That's what we'll be focusing on here. We'll mostly assume that the mass of an object remains constant. Yes, but in conservation of momentum, the mass can actually change, but you'll see that when we get to it. Okay. Now, this is how you can define the change in momentum. You can say it's mass times the change in velocity, but I really prefer you use this because even if you begin by saying this, you are still going to use that. So I highly recommend the pink one as the formula for the change in momentum because it's only the velocity which is changing. Okay. I just told you that the net force is the one that affects the momentum of an object. But now I'm going to state for you Newton's second law in terms of momentum. Newton's second law, I'll just say ITO. So you'll know that ITO means in terms of momentum. And please know how to state this. So this is what Isaac Newton said because he was a genius and he thought, why not? Might as well say this. He said, the net force that acts on an object is actually equal to the rate of change in momentum of the object in the direction of the net force. And this is what Isaac Newton said. Think of it. The net force that acts on an object is not directly proportional, no. It is actually equal to the rate of change in momentum in the direction of the net force. So this one is making it clear that the change in momentum is in the direction of the net force. We know that the momentum is in the direction of the velocity, yes? But the change in momentum is in the direction of the net force. In the same way that the acceleration is in the direction of the net force. Now, if you remember well, we know that according to Newton's second law, F net equals ma. But we also know that acceleration is defined as the rate of change in velocity. The word rate means something divided by time. That's the meaning of rate. The rate of change in this thing, it means time is being divided by, I don't know, whatever it is. What am I saying? Something is being divided by time. Yes. Now then, if we take our second equation and we substitute it into the first equation, we find that the net force is now going to be defined as the mass, which is multiplied by the acceleration. But we know that the acceleration is defined as the rate of change in velocity. And multiplying numerator by numerator, we get m change in v divided by the change in time. And we know what is m times change in v. It's simply the change in momentum. Do you remember that? So this is how we state Newton's second law in terms of momentum. I can just write it down here and say, well, the net force acting on an object is equal to the rate of change in momentum. And of course, this change in momentum is in the direction of the net force. Yes. Now, I tell you, who is this directed to? Let's take you, Sihle, and we'll also take Kogetso. This is what I tell you. I say, the momentum of an object changes by 10 kilograms meter per second. Well, this is what I tell you. The momentum of an object changes by 10 kilogram meter per second. Now, I want you to tell me, what is this 10 referring to? Does it mean that the 10 is the final momentum, or the 10 is the initial momentum, or the 10 is the change in momentum? So which one of those three is this 10 referring to? Over to you, Sihle. Well, if you're speaking, then your microphone is off. Please unmute it and speak.
Can you please repeat the question, sir?
Sorry?
Can you please repeat the question?
Oh, the question is, I'm telling you, I'm saying to you, the momentum of an object changes by 10 kilogram meter per second. This is what I'm telling you. Now I'm asking you to tell me, is this 10 kilogram meter per second going to be the final momentum, or is it going to be the initial momentum, or is it going to be the change in momentum? Which one do you think it's going to be?
I think it's going to be the change in momentum.
Please speak up, Elsie. I can't hear you well.
I think it's going to be the change in momentum.
You say it's going to be the change in momentum. Is that what you're saying? In other words, this. Is that what you are saying?
Yes, sir.
Okay. Thank you, Elsie. So, I saw your hand was up, Mamohali. You may go on. Or maybe it was a mistake. Okay. So before I tell you the answer, I just need to type A. I need you to type in the chat box if you agree with her. So you can just type an I if you believe that the 10 is referring to change in P. Just because I typed an I doesn't mean I believe it. I was just showing you how to use the chat box. So Carol agrees, Malishaba, Mila, Anna, Mamohali. Gundo Kogetso. Seems like the council is unanimous. Okay. Thank you so much for that, everyone. Now I'm changing my question. So what is the question changing to? I'm sorry about that. Yes, I was saying now I'm changing the question. What is the question changing to? Not sure what's the matter now. I think maybe that's because they did that. Right. The question is changing by one word, to. The momentum of an object changes to 10 kilogram meter per second. Once again, you need to decide which of those is it referring to. So this one is yours, Gogetso.
I'm not sure what it is momentum timing.
You are not sure. Okay, I'll say you can choose a person who can assist you. Just call out a name and the person will gladly assist you.
The guy is Gungo. I think it's Gungo or something. Sorry if I'm not pronouncing it correct.
Okay, no, that's okay, I'll say. Gundase, I'm also not sure if I'm saying it correctly, sir. Please begin by helping us with the pronunciation of your name, sir, and then get on with the question.
So yes, it is Gundo, and I think it's the final momentum.
So you think it refers to the final momentum? Okay. Well, once again, I need you to type an I in the chat box if you strongly believe that it's referring to the final momentum. Mamutolo I Nila, I Anna, I Malshaba. Okay, no. Once again, it's unanimous. Yes, thank you so much, everyone. I'm asking you this because it's rather important. There are questions that you'll encounter which need you to be able to tell which one of those two is it referring to, as you will see as we come back and do the things. So, yes.